This is an answer key for the Math 1111 review for test number 1. And I want to work through the problems that are on that review. So question number 1 asks you to simplify the square root of 162 x cubed y to the ninth. Now there are a variety of ways you can go about simplifying the radical. What you have to remember is that when you're simplifying a square root, you have to ensure that there are no perfect squares under the radical, and that if it is a fraction, that there's no radicals in the denominator. So those are the two primary things you have to be sure of. So I tend to do it and I just break down the value. So I'm going to factor, if you will, 162. That would be 2 times 81. 81 is 9 times 9, and I could keep going, but if I break that down into 2 times 9 times 9, and then I have x to the third and y to the ninth, so I would have 9 y's. Okay, the way I look at it, since this is a square root, you have to be a perfect square, you would have to have 2 of that particular number or that particular variable. So I notice that I have a pair of 9s, I have one pair of x's, I have 1, 2, 3, 4 pairs of y's. So if you have a perfect pair, then they're going to get removed from the radical. So I'm going to bring out this 9, I'm going to bring out 1x, and I bring out 4 y's. Okay, and what's left is 2xy. So in simplified form, the square root of 162 x cubed y to the ninth is 9x y to the fourth times the square root of 2xy. Okay, question number 2 is, again, it's a simplification problem, and we have the value 490. So if I break down 490, I know that that's 10 times 49. 10 is 2 times 5, and 49 is 7 times 7. So that gives me, let's see, 2 times 5 times 7 times 7. I have 5 x's and 3 y's. Again, it's a square root, so I'm looking for pairs of numbers. So I have a pair of 7s. I have 2 pairs of x's and 1 pairs of y. So again, the pairs get removed from the radical. So I have a 7. I have 2 x's, so x squared, y. Underneath, I have a 2 and a 5. 2 times 5 would be 10. Then I have x and y. So the square root of 490 x to the fifth y to the third simplifies to 7x squared y times the square root of 10xy. And again, remember, if you struggle with knowing where that 10 kind of jump out there at you, remember 2 times 5 is 10. Question number 3 asks you to simplify by rationalizing the denominator and simplifying. Okay, so they tell you in this instruction the technique to use, because one of the things about working with radicals is you cannot have a radical in the denominator of a fraction, which we do have here in this particular case. So we rationalize the denominator. So we have 42 over 6 minus the square root of 15. The idea of rationalizing the denominator, we're going to multiply the numerator and the denominator by the conjugate of the current denominator. The conjugate is the same two pieces, so I'm still going to have a 6 and a square root 15, but it becomes plus. Okay, you have one that's plus and one that's minus. Okay, so you have the same two pieces. The original was negative or minus, so this one is plus. And then we have to multiply the numerator times 42 times 6 plus square root 15. Then we're also going to multiply the denominators together. Okay, so to multiply the numerators, we need to use the distributive property. So we're going to do 42 times 6, and I can't do that one in my head. I'm going to use my calculator. 42 times 6 is 252, and then 42 times square root 15 is plus 42 square root 15. And then I'm going to multiply the denominators together. You have basically a binomial times a binomial. I'm going to use full. So I do first 6 times 6 is 36. Outside, 6 times positive square root 15 is plus 6 square root 15. Inside, minus square root 15 times 6 is minus 6 square root 15. And then last, square root 15 times square root 15, I'd have negative 15. It's the square root of 225, and the square root of 225 is 15. Okay, so then I'm going to simplify, do what addition, subtraction I can do in the numerator and the denominator. Okay, in the numerator, I cannot combine anything. I have 252 plus 42 times the square root of 15. In the denominator, 6 square root 15 minus 6 square root 15, that's 0. So then I have 36 minus 15, which gives me a value of 21. And so then I want to see, can I simplify this any at all? So if I think about it, I have 252 divided by 21 plus 42 square root 15 over 21, and I want to see if I can simplify that. So 252 divided by 21 gives me a value of 12 plus 42 divided by 21 is 2, so I get 2 on the square root of 15. This is ultimately your answer. Okay, when you get 42 divided by 6 minus square root 15 rationalized and simplified, you always want to simplify any kind of fraction that you have. You get 12 plus 2 square root 15. Okay. Number 4 is a similar problem. Again, it tells you, if you're careful, it tells you in the instructions to simplify, again, by rationalizing the denominator. So we have 5 over 9 plus square root 6. Again, our conjugate that we're going to multiply the numerator and the denominator by is the same two pieces. So we have 9 and square root 6. It's originally a plus, so I need a minus. So I have 9 minus square root 6. And again, we're going to multiply numerator times numerator and denominator times denominator. So we have, using the distributive property, 5 times 9 is 45. 5 times minus 6 is minus 5 square root 6. Then in the denominator, we do full. 9 times 9 is 81. 9 times minus 6 is minus 9 square root 6. Positive square root 6 times 9 is plus 9 square root 6. And then square root 6 times negative square root 6 is minus 6. Then we go back and we combine what terms we're able to combine. So I have 45 minus 5 square root 6 minus 9 square root 6 plus 9 square root 6, that's 0. 81 minus 6 is 75. And again, I'm going to break it apart. I have 45 over 75 minus 5 square root 6 over 75, and I'm going to see if I'm able to simplify that any at all. Okay, so 45 and 75 will both divide by 5. 5 goes into 45 9 times. 5 goes into 75. I believe that's 15 times. And then I noticed that both of those numbers can also be divided by 3. So 9 divided by 3 is 3. 9 divided, or excuse me, 15 divided by 3 is 5. So I have 3/5. You always put it in lowest terms. Minus 5 goes into 75 15 times. So you'd have square root 6 over 15. It could be written that way, or if you wanted to leave it with that denominator of 15, you could see it written 9 minus square root 6 over 15. You could do it either way. It just depends on how they ask you to write it, whether they want it in the standard form or not. So either answer is acceptable. And if it's multiple choice, you may need to know that either answer is acceptable. Okay, then question 5 asks you to factor 49x squared plus 36y squared. I notice that this is a binomial. It has two terms. And typically when we have two terms, we think about either the difference of two squares or the sum of two cubes or the difference of two cubes. So I have to think about which pattern, if you will, do I have in this problem. One of the first things that I notice is that I have these exponents of 2. So that really makes me think, at least initially, that I'm dealing with a square. So then I want to check the other things, so I want to think about, is the first term a perfect square? It does appear to be. 30 is the second term, 36y squared, a perfect square? It does appear to be. But then the key thing is, to be a difference, you have to have a minus sign, and I have a plus sign. So because I have a plus sign, it does not fit the pattern for the difference of two squares, which means this particular binomial is not factorable. You cannot factor this particular polynomial. Okay, moving on. The next one says factor the following. You have 25x squared plus 60x plus 36. There's, again, a variety of ways you can do it. Some people do it by trial and error. Some people do it by grouping. I tend to use what's called the box method. And that may be a little challenging with these really big numbers, but we're going to give it a shot. So I start with a box. The first term goes in the upper left, so 25x squared. The constant, or the last term, goes in the lower right. And then I'm going to multiply those numbers together. So 25x squared times 36 gives me 900x squared. So then I need to list out all of the numbers that multiply together to give me 900. So I have 1 and 900, 2 and 450, 3 and 300. Let's see, does 4 go? Yep, 4 times 225, 5 times 180, 6 times 150. I don't believe 7 will go. 8, 9 times 100, 10 times 90. I don't believe 11 goes. 12. It's 12 times 75. Let's see. 14 I don't believe goes. 15. I have 15 times 60. 18 times 50. 20 times 45. 25 times 36, that was the pair we used. Gosh, we got a lot of numbers. 25 times 36. Let's see, 30 times 30. And okay, so I think I'm good. I think I start repeating at that point. Okay, so if we list out again, and that's a lot for 900, but we list out all of the pairs of numbers that will multiply to 900. And then I need to find the pair that will add to 60. Well, that's 30 and 30. And I want it to be a positive 60. So both of these will be positive. So that's what goes in the other two blocks. I have positive 30x and positive 30x. And then I'm going to find the greatest common factor for each row and each column. So for 25x squared plus 30x, I have 5x squared, or excuse me, not x squared, just 5x, excuse me. 30x plus 36, I have a common factor of 6, and it's positive. 25x squared plus 30x, I have a common factor of 5x. 30x plus 36, again, I have a common factor of 6. So I have 5x plus 6 times 5x plus 6. Whatever you have on the column and whatever you have on the rows becomes your two factors. Again, you could have done that by trial and error, which some people prefer. All right, number 7 asks you to divide and simplify the rational expression. Okay, first off, I want to think about the division. And remember, to divide, we flip and multiply. So if I rewrite this problem, it becomes x squared plus x minus 56 over x squared minus 1 times, and we flip the divisor, so it becomes 2x plus 2 over x minus 7. And then to complete the division or simplification, we have to first factor everything. I need to factor all of these. I'm going to factor x squared plus x minus 56. I'm going to use trial and error. I need a pair of numbers that multiply to 56 but subtract to 1. That's 7 and 8. We want a positive 1, so the larger number is positive and the smaller one is negative. X squared minus 1, which is in the denominator, is a difference of two squares. It factors as x plus 1, x minus 1, times, in 2x plus 2 has a common factor of 2, so I factor it out. And x minus 7 does not factor any further than it already is. So I have everything factored. It's like you got to be a factoring maniac. Okay, then we come back and we look to see, do we have anything in common? And I always say it's kind of like the bow tie, because you're going to look diagonally. Okay, so I notice I have an x minus 7 and an x minus 7. On the other diagonal, I have x plus 1 and x plus 1. Then I check vertically. So I'm simplifying on the bow tie. X plus 8 and x minus 1, there's nothing in common. I have a 2 left in the numerator, so there's nothing in common. So what I have left is 2 times x plus 8 all over x minus 1, and that's your answer. Okay, so we did the division by flipping and multiplying, and then we simplified. To simplify, you have to factor everything first. Okay, and then make sure I call it simplifying on the bow tie. Question 8 asks you to multiply the following. So it's already set up as a multiplication problem. Whoops, pardon me. Kind of hit the wrong button there. So we have x squared minus 9 divided by x squared plus 3x minus 18 times x plus 6 over x minus 3. Again, the first step is already set up as a multiplication problem. The first step is to factor everything that can possibly be factored. So x squared minus 9 is the difference of two squares. So it factors as x plus 3, x minus 3. In the denominator, again, I'm going to use trial and error. I need a pair of numbers that multiply to 18 but will subtract to 3. So I believe that gives me 6 and 3. And I need a plus 6 and a minus 3 times x plus 6 does not factor, and x minus 3 does not factor. So once everything is factored, we then simplify on the bow tie. So if I check diagonally, I have x minus 3 and x minus 3. On the other diagonal, I have x plus 6, x plus 6. On the vertical, I have x plus 3 and x minus 3. That doesn't simplify. And then everything else has been divided out on the left, or excuse me, on the right. So I'm left with x plus 3, x minus 3. And that is your answer when you multiply those two rational expressions and simplify. And again, you may think, well, big deal, who cares? But guys, especially when you get on up into calculus, working with something like x plus 3, x minus 3 is going to be a whole lot easier than trying to deal with x squared minus 9 over x squared plus 3x minus 18 times x plus 6 over x minus 3. Okay, so it's important that you think about that simplification. Again, it's a skill that you're going to need later on. Okay, number 9 says solve the following inequality. It says write your answer in interval notation. Okay, so solving an inequality is very much like solving an equation. The biggest thing you have to remember is when you're dealing with an inequality, if you multiply or divide by a negative number, you have to reverse or flip the inequality symbol. So to solve the inequality, again, much like you would solve an equation, you have to get all of the x's together on one side and all of the constants or numbers together on the other side. I tend to put the letters on the left, so I'm going to subtract x from either side so that I have 2x minus 1x is 1x minus 12 is greater than or equal to 8 because x minus x is 0. I'm then going to add 12 to either side, so I have x is greater than or equal to 8 plus 12 is 20. Notice I did not have to invert or flip the inequality symbol because I did not multiply or divide by a negative number. Now the instructions ask you to write your answer in interval notation. Sometimes for interval notation, it's easier if you start with a number line. So I'm going to think about what this particular answer would look like on a number line. If I were doing it on a number line, I would have a circle at 20, and that circle would be colored in because it is equal to 20, which means I can use that particular value. And then I want any number that's greater than 20. Greater than numbers are always to the right. Okay, so there's a picture of it on a number line. So as an interval, we're going to start at 20 and we keep going to forever, which is infinity. Since we can use 20, we use a square bracket and we put a parenthesis at infinity every time, all the time. Infinity always gets a parenthesis. So your answer, is for 2x minus 12 greater than or equal to x plus 8 is you can choose any number equal to or greater than 20. All right. Number 10 says solve the following inequality. So again, we start with an inequality. We have negative x minus 7 is less than negative 4x plus 8. Again, we need to try to get all of the variables together on one side and all of the constants together on the other side. Again, I tend to put the letters or the variables on the left. So I'm going to add 4x, negative 1x plus 4x is 3x, minus 7 is less than negative 4x plus 4x is 0. We have 8. I then need to add 7 to either side to get the numbers together. So I have 3x is less than 15. I'm then going, to divide both sides by 3. Notice I'm dividing by a positive 3. So I don't have to worry about inverting the symbol. So I have x is less than 5. So again, if I think about what that looks like on a number line, okay, I have 5, but in this case, it's not equal to 5. I'm not able to use 5 as a solution, and then I want values that are less. So the 5 is left as an open circle on the number line, and it's let to the left. Okay, when you write an interval, we always go from smallest to largest, or we read the number line from left to right. So I would have from negative infinity all the way up to 5. Again, infinity, even if it's negative, gets a parenthesis. We cannot include the 5 because it's not equal, so we use a parenthesis. So the interval is from negative infinity to 5. All right, number 11 asks us to subtract the following complex numbers and then enter the answer in, in simplest form. Okay, the biggest thing with subtraction is remembering to make sure you distribute. There's like an understood one here. So we have negative 7 minus 8i minus 1 times 2 is minus 2. Minus 1 times 8 is minus 8i. Okay, make sure you distribute that negative. And then we simply combine like terms. Like terms means you combine the real, negative 7, and minus 2. So that's negative 9. And you combine the imaginary. Minus 8i minus 8i is minus 16i. It does ask us to put our answer in that form, a plus bi. In this case, we have negative 9, minus 16i. It may help you to remember, especially as we move to the next question, that I is defined as the square root of negative 1. And I mentioned to you earlier that you cannot have a radical in the denominator of a fraction, which also means you cannot have an I, or the imaginary unit, in the denominator of the fraction. So when we divide these complex numbers, we kind of use that same technique in a sense that we're going to rationalize the denominator. Okay, because I've got to get the I out of the denominator. So my question is negative 38 plus 18i divided by negative 3 plus 5i. So again, pardon me, I got the yawns all of a sudden. Okay, you're going to have the same two partners, negative 3 and 5i. And it's originally plus, and it becomes a minus. And then we're going to multiply the numerators together, multiply the denominators together. Again, it's that idea of that rationalization, getting rid of the imaginary unit. Okay, so in the numerator, and again, these are kind of big numbers, so we have negative 38 times negative 3, which is 114. Then we do negative 38 times negative 5i gives me plus, negative times a negative is a plus, 190i. 18i times minus 3 is minus 54i. 18i times 5i gives me positive times a negative is a negative 90i squared. Then we do the denominator. Negative 3 times negative 3 is positive 9. Negative 3 times negative 5i is plus 15i. 5i times minus 3 is minus 15i. 5i times minus 5i is minus 25i squared. Okay, then I'm going to go back and combine together what I can in the numerator and the denominator. So I have 190i minus 54i. So 190 minus 54. So I have 114 plus 136i minus 90i squared. In the denominator, 15i minus 15i. Okay, that zeroes out. So I have 9 minus 25i squared. The other thing you have to remember whenever you're dealing with imaginary numbers is that I squared is actually a real number. Okay, I squared by definition is always equal to the real number -1, and you should never ever have an I squared left in the answer to a problem. So I need to replace this I squared with -1. I'm going to do the math. So I have 114 plus 136i, -90 times -1, negative times a negative is a positive 90. Then I have 9, -25 times -1 is plus 25. Okay. So again, we're back to combining like terms. 114 plus 90 gives me 204 plus 136i. 9 plus 25 is 34. And then I need to see, because again, look at how they want the answer. They want it in that form, a plus bi. Well, I don't quite have it in that form yet. Okay, so I'm going to break this apart and get it in that format, and then I may have to do some simplifying too. So I have 204 over 34 plus 136i over 34. Okay, so I've broken it apart, and I need to see if I can simplify. 204 divided by 34 is 6. 136 divided by 34 is 4. So I simplify to 6 plus 4i. You simplify the fraction. This is ultimately your final answer in that form, a plus bi. Now, it takes a lot of steps to get there. Using the colors might be helpful to you. Okay, writing down all of the steps. I've tried not to leave any of the steps out. But when you're dividing complex numbers, it's like you're rationalizing the denominator to remove the I from the denominator. All right, question 13, I believe is where we are. Let's see. Yep. It says, which of the following is a rational number? Okay, this one just really requires you to remember or recall what a rational number is. Rational means that it can be written as a fraction. Okay, rational is kind of a fancy word to indicate that it can be a fraction. It could be a whole number, because I can write a whole number as a fraction. It can be a terminating or a repeating decimal. Okay, so I have to think about it. If I look at the square root of 19 in my calculator, I get this big, big, long decimal number. It does not repeat, so that is not a rational number. 0.84844, okay, that's not repeating. 0.76767676, that one does repeat, so that makes that one rational. 5.63 is a terminating decimal. -6, I can write that as -6 over 1, so it is rational. Square root of 7, again, I get this big long decimal value, so that is not rational. Then question 14 kind of flips it and says, okay, what's irrational? Irrational are those, I call them the gloobly glops. They're the big, long decimal numbers that do not repeat, they do not terminate, they just seem to go on forever and ever. So again, if we look at square root of 19 in our calculator, it goes on and on forever and ever, and there's no repeating pattern. Even this second one, 0.84, 0.844, 8444, there's a pattern to it, but it is not repeating, and it goes on forever and ever, as indicated by the dot, 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 dot. So that one's also irrational. And then square root of 7 is a big long number. If you look at 0.76767676, it does have dot dot dot, but it's a pattern. It repeats 0.767676767676, and it would go on forever and ever. 5.63 is a terminating decimal, and -6 is a whole number. Okay, so just be careful. You just need to know or understand the definition of rational or irrational. Question 15 says to simplify the following exponential expression, and your final answer should contain only positive exponents. This is very similar to simplifying your fraction. Okay, so like simplifying fractions again, we're going to multiply these together, but I can simplify first, like I did with the rational expressions. I have 1y in the numerator and 6 in the denominator, so I can divide one of those out and leave 5 in the denominator. Again, looking at that diagonal. Looking at the other side, I have x to the fourth and x to the fourth. Okay, so I have the same number. They're going to divide out or go away. Some people say cancel. Okay, and then we're going to multiply. 2 times -4 is -8. And 1, if you will, times y to the fifth gives me y to the fifth. So there's your answer. -8 divided by y to the fifth. Okay. And it has positive exponents. I don't have any duplications in the variables, and I don't have anything else that'll simplify. Question 16, it looks really weird. It might help you to let me rewrite it where you can maybe see it a little bit better. We have x to the fourth y squared over z to the -4, and that's actually raised the exponent -3. There's several ways or several approaches you can take here. Again, we want to eliminate the parentheses and do what we can. So I'm going to distribute this -3 to all of the pieces inside so that I have x to the -12, y to the -6 over z to the +12. -4 times -3 is +12. Okay, again, we can only have positive exponents. The way we make them positive is we move them to the denominator or numerator. We move them up or down in the fraction. So I have x to the -12. It's going to get moved down, become x to the 12. Y to the -6 gets moved down so that it becomes positive. Z to the 12th is already there and it's positive. I need a placeholder in the numerator, so we put a 1 as our placeholder. So the answer is 1 over x to the 12th, y to the 6th, z to the 12th. Again, I have all positive exponents. There's no repeat in the variables, and we work it from there. All right, let's see where we are. Okay, question 17 asks you to solve the quadratic and select all the correct answers. So meaning that probably it's like a multiple choice, but you have to choose all the ones that apply in GoView. Okay, so there's different ways to solve a quadratic. Most students, quite honestly, in the end prefer to use a quadratic formula, but you can solve by factoring, or and again, there's other options, but I would go with quadratic formula as my second option. If you don't remember what that formula is, it is x equals the square root, whoops, sorry. X is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Now this first problem, again, it strikes me kind of off, and again, I've been doing this for a while, but it strikes me that I probably can factor this one. Again, just to demonstrate the box method, okay? The first term goes in the upper left, 5x squared. The last term goes in the lower right. So I have 5x squared and 2. So 5x squared times 2 is 10. So I have 1 times 10, 2 times 5. And I need the pair that will add to 11. Okay, I need the pair that will add to 11, which is 1 and 10. And you want them both to be negative because you want a negative 11. So I have negative 1x and negative 10x. So then I'm going to look for those common factors all the way around. Okay, 5x squared minus 1x is x. Negative 10x and 2, I have a 2 in common. 5x squared minus 10x, I have a 5 and an x. Minus 1x, I'm sorry, this should be a minus. Minus 1x and 2, I have a common factor of 1, and it should be a minus. You always use the sign right here. So ultimately, this factors into x minus 2 times 5x minus 1, and that equals 0. Then we know that one of those pieces, either x minus 2 had to be 0 or 5x minus 1 had to be 0. Because if we multiply any two things together, a times b equals 0. As long as one of those numbers is 0, I know that I get 0, whether I do 1 times 0, 0 times 1, 2 times 0, 0 times 2. If one of the numbers is 0, my ultimate final answer is 0. So I'm going to add 2, add 2. So I get x equals positive 2 as one answer. Then on the other side, I'm going to add 1, add 1. I get 5x equals 1. Divide by 5, divide by 5. X equals 1/5. So I have two answers. One of my answers is 1/5. The other answer is positive 2. And typically with a quadratic, you're going to have two answers. Now, had you done that by quadratic formula, you should have arrived at the same answers. Okay, I'm going to do this question just to show you how to do both. I'm going to do this particular problem by the quadratic formula. Okay, so in this problem, the a is the number in front of the squared term, the b is the number in front of the x, and the c is the constant. And if we're doing quadratic formula, opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And it becomes a straight substitution problem. Okay, so I would have the opposite of negative 26 plus or minus the square root of negative 26 squared minus 4 times 9 times minus 3 all over 2 times 9. Okay, so then I got to do some math. Okay, so the opposite of negative 26 is positive 26 plus or minus the square root. Okay, I'm going to get my calculator out. Negative 26 squared, negative 26 times negative 26 is 676. Minus 4 times 9 times negative 3 is plus 108 over 18. So I have 26 plus or minus the square root. 676 plus 108 is 784 over 18. And then I need to try to simplify that radical if it will. Let's see. I'm not familiar with whether or not that's a perfect square, so let's check it out. Oh, it is a perfect square. So we have 26 plus or minus the square root of 28. 784 is actually the perfect square of 28 over 18. So you actually have two answers here because you have 26 plus 28 divided by 18. So that gives us 26 plus 28, which is 54, divided by 18. So we get 54 divided by 18, which is positive 3. So one of our answers is 3. We also have 26 minus 28 over 18. That gives us negative 2 over 18, which simplifies to negative 1 over 9. So our two answers using quadratic formula are 3 and negative 1/9. And again, you can do either method on either problem. Okay, again, a lot of students prefer quadratic formula. Just be careful, make sure you're applying the formula correctly. All right, number 19. Ask you to find the midpoint between of a line segment that has endpoints -4, -5, and 2, 5. Guys, this is a formula to find the midpoint between 2 points. You add the x values, so x1 plus x2, and we divide by 2. Then you do y1 plus y2 and divide by 2. It's a straight flat out substitution problem. Okay, so I have my first ordered pair would be my x1, y1. My second ordered pair would be my x2, y2. Okay, so I have x1 is -4 plus 2 divided by 2. For y, I have -5 plus 5 over 2. And then we're going to simplify. -4 plus 2 is -2 over 2. -5 plus 5 is 0 over 2. So ultimately, -2 over 2 is -1. 0 over 2 is 0. So the ordered pair that represents the midpoint is -1, 0. It's a straight flat out formula substitution. You are allowed to use your notes, so I would make sure that you have that formula handy. The next question is a distance problem. Again, distance is going to be a flat out formula problem. So you have the distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so again, it's a substitution. You have x1 y1, x2, y2. Okay, so we have the square root of 2 minus a minus 4 is plus 4 squared plus 5 minus a minus 5, which is plus 5 squared. And then I got to do the math. Okay, so we have 2 plus 4 is 6 squared plus 5 plus 5 is 10 squared. 6 squared is 36. 10 squared is 100. So that gives me the square root of 136. Now it does say to leave your answer in radical form, but it also says in simplest radical form. So I need to make sure I don't have a perfect square in here. So 136 would be, let's see, 2 times 68. 68 is 2 times 34, and 34 is 2 times 17. So I have 2 times 2 times 2 times 17. Notice that I do have there a pair of 2's. So that's going to simplify so that I have 2 square root of 2 times 7, which is 2 times 17. So the most appropriate answer is 2 on the square root of 34. All right, next one. Again, ask you to find the distance again between 2 points. Again, it's a straight, flat out plug and chug. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Again, it's a straight, flat out plug and chug. You have x1, y1, x2, y2. So I have -8 minus a minus 4, which is plus 4 squared, plus 1 minus a minus 9 makes plus 9 squared. So that gives me the square root of -4 squared plus 10 squared. So I have the square root of 16 plus 100. Watch your signs. -4 times -4 is positive 16. So that gives me the square root of 116. If I check that out, that's 2 times 58. 58 is 2 times 29. So I have 2 times 2 times 29. Okay, so I have a pair of 2's, so this simplifies as the 2 on the square root of 29. And that would be your most appropriate answer in simplified radical form. All right, 22 and 23 deals with circles and looking at the graphs. Okay, it may help you here to recognize before we go over and look at the graphs in GoView that if you're looking at this circle, remember this is x minus h squared plus y minus k squared equals r squared. So my radius would be 2 and my center, which corresponds to h and k, would be 2, -5. So that helps me if I know the center point when I go over to GoView to look at these graphs. I know that I need to find my center point, which is at +2 -5. Okay, so if I look at this first graph here, I'm at -2, +5. Eh. So that's a no. Okay, then we look at the second one and we're at +2, +5. Eh. Okay, then if I scroll to the third one, I am at 2, -5. And then it does appear to have a radius of 2. Okay, if you look at the next one, it also is at 2, -5, but the radius is bigger. Okay, so I need the smaller one. So I would choose this one. I believe your last choice there is you don't have a none of these. Okay, so it's trial, if you recognize, the easiest thing to do is to recognize what your center and radius is and then look for that particular graph. The last one here, again, is a circle, and with my center point, I'm going to have -3, -4, and my radius is going to be 3. So I need to determine which graph initially has my center point, okay, and then check my radius. So let's see, I'm looking for -3, -4. So this one appears to be at -3, or excuse me, +3, -4. Nope. I don't know if it's none of these yet. I hadn't got that far. Then this one looks like it is -3, -4. Okay, and my radius does look like it's about 3. So it could be that one. I'm going to double check a few more. Okay, this one is at +3. No. This one's +3, +4. Nope. Okay, so it has to be this one. Okay, I hope you find that helpful. To help you see what the answers are, I would take really, really detailed notes as you're working through the review, because you will be able to refer to them when you are taking the actual test.